Did you know that a tiny, almost microscopic imbalance in your blood glucose can completely derail your energy levels and just tank your mood? Welcome back to our explainer. Today we're looking at something that isn't just a textbook concept you need to memorize for your O-level exams. This is a real-world mechanism. It dictates how you feel, how you focus, and how you perform every single day. So mastering this topic doesn't just mean easy exam marks. It means finally understanding the literal fuel injection system of your own body. Okay, let's dive right into this. Today, we're mastering blood glucose regulation, which, if you think about it, acts exactly like your body's internal thermostat. But instead of regulating the temperature in the room, it's constantly dialing your personal energy supply up and down. To master this, we're going to cover the body's messaging system, endocrine versus exocrine glands, the blood glucose thermostat itself, and then we'll run through two scenarios, after a meal and during exercise, before finishing up with some common exam traps. So part 1, the body's messaging system. Before we even talk about blood sugar, we have to understand exactly how the body communicates with itself to manage long-term processes like growth, metabolism, and energy distribution. On a macro level, hormones are chemical messengers. But zooming in on the micro level, watch how they work here. They're sent by endocrine glands, they travel straight into the flowing tunnel of the bloodstream and head directly to specific target organs. You can really just think of hormones as your body's internal WhatsApp network. It ensures that distant cells get the exact right message at the exact right time to maintain internal balance. Moving on to part 2, endocrine versus exocrine glands. Now, what's really interesting about this is the key architectural difference in how these glands actually release their chemical messages. Notice how endocrine glands on the left are ductless. They secrete chemicals directly across the boundaries straight into the bloodstream. Our prime example here, and honestly the hero of our story today, is the pancreas. Exocrine glands, on the other hand, utilize these physical tube structures called ducts to release substances to very specific external locations, like sweat onto your skin. But for blood glucose regulation, we are strictly focusing on the ductless, direct-to-bloodstream endocrine system. Which brings us to part 3, the blood glucose thermostat. Zooming in on the pancreas, we've got two core variables that keep your engine running smoothly: insulin and glucagon. Let's walk through this loop. In step 1, an imbalance is detected, meaning blood glucose is either too high or too low. In step 2, your pancreas detects this gradient change and immediately deploys specific hormones into the blood, either insulin or glucagon. And by step 3, you can see the scale levels out horizontally. Balance, or what we call homeostasis, is restored to stable levels in this continuous looping feedback cycle. Let's see this in action with part 4, scenario after a meal. And this brilliantly illustrates the cycle right after you eat. Look at step 1. Those thick red upward arrows represent your blood glucose levels rapidly rising. Moving to step 2, the pancreas reacts to this sharp upward spike by releasing insulin, which, as you can see, acts as a literal key. In step 3, that insulin key inserts right into the cell membrane boundary. It unlocks the doors, allowing glucose to flow out of the bloodstream and directly into your cells for immediate energy. Any excess glucose? Well, that's routed straight into the liver, where it gets compacted and stored as a reserve called glycogen. Now for the opposite end of the spectrum, part 5, scenario during exercise. So what happens when your body suddenly demands a massive amount of fuel to keep your muscles firing? In step 1, you're working out, and those thick blue downward arrows indicate your blood glucose dropping rapidly as your muscles just consume that fuel. In step 2, the pancreas registers this downward gradient and completely switches gears. It stops the insulin and instead releases glucagon, which is your literal signal. In step 3, this signal travels to the liver like a blaring emergency alarm. The liver immediately unpacks that stored glycogen, converts it back into glucose, and dumps it right back into the bloodstream to keep you moving. Finally, let's look at part 6, common exam traps. So the crucial point here, and if you want to secure those top grades, you really must know exactly how to articulate these mechanical steps without confusing the variables. Trap number 1, mixing up the roles. Just remember the directional arrows. Insulin pushes glucose levels down, while glucagon pulls them up. Trap number 2, thinking insulin acts immediately, like a nervous system reflex. It totally doesn't. As the circulatory vector shows us, hormones have to physically travel through the blood fluid, which builds in a natural time delay. And trap number 3, believing insulin is just a storage hormone. Nope, it actively unlocks your muscle cells to promote immediate glucose usage for energy, right in the moment. Let's anchor these visual metaphors into your memory one last time. If you take away absolutely anything from this explainer today, remember this simple equation. Insulin equals the key for cellular entry, glucagon equals the signal for liver release. Understanding this beautiful microscopic dance is literally the secret to mastering your endocrine system. So I'll leave you with this thought to ponder the next time you feel a mid-afternoon crash or a post-workout high. Based on what you've just learned, who is truly in control of your energy today?